All right, thanks everybody for coming. I am not using a microphone in this room, and Nora won't either. We're just going to be projecting, but we are having our voices recorded via phone so that we can have some of this information shared online later. We also have one participant on Zoom with us who is a key partner in some of the work that I'll be talking about tonight. So I might be able to defer to her for questions, but again, we'll just roll with the punches for tech. We weren't planning on this being a hybrid meeting, and unfortunately she's under the weather. Otherwise we would have been a little more streamlined tonight. But thank you all for being here. My name is Alexis. I use she, her pronouns. I'm coordinator for the Tryon Creek Watershed Council. And I'm really excited for the science talk tonight. Glenn, we might see about turning off that little X pop up on there. I am sharing the time tonight with Nora Boylan from Wolf Water Resources. And you might have seen on the flyer, we kind of had the title of the talk, and then in that fish pop-up, we said we would also be sharing about fish in the Tryon Creek watershed and fish updates. And so that's what we're actually starting with today. I'm gonna speak for hopefully not too long. This is the kind of topic where I could talk for hours and hours. I'm not gonna do that. I'm gonna try and keep it within like 20 or 30 minutes for us, so that we can turn it over to Nora and get us all out of here, probably by about 7:30. So I think that's all I wanted to say for the start. We can go ahead, Glenn, and switch over to the next slide. So two-part science talk. As mentioned, this is what I will be presenting on. So whenever I start kind of any conversations with folks about the Tryon Creek watershed and about stewarding the watershed, one of the things that is built into a lot of discussions and is really important is a land acknowledgement. And as a environmental restoration practitioner, the work that I'm doing is not new, right? There's a lot of emerging Western science that's really exciting, but it's also really important and really grounding for us to talk about the fact that this land has been stewarded for millennia, since time immemorial, by Indigenous people here. And I really also want to drive in the fact that these lands were really actively managed, not just passively lived on. A lot of us might have, gone to school and learned something different, but there's good work these days to really elevate traditional ecological knowledge, and really great collaboration between Western scientists and Indigenous folks that are managing the land. And so the names of the tribes and bands of the Columbia and Willamette rivers who might have used Tryon Creek, lived in Tryon Creek, and consider Tryon Creek and the waterways here as their relatives include the Clackamas Chinook, the Willamette Tumwater, the Wasco Wishram, the Watlata, the Multnomah, and other Chinookic peoples, as well as the Tualatin Kalapuya, the Cayuse, and the Molalla, and as I said, other tribes and bands of the Columbia and Willamette rivers. It's important to just recognize that we're here today because of what was forced, of sacrifices that were forced upon Indigenous people. And there's a way that we can all basically be involved in being better stewards and better relatives to our Indigenous community members. One of the things that you can get involved in is signing a petition to support the Chinook Indian Nation's federal recognition. They have been deprived of a lot of really important resources. Okay, next slide. Watersheds work like the little Russian nesting dolls. It's a word that we hear a lot, but watersheds are just kind of a matter of scale and how zoomed in or how zoomed out you are on a given part of the landscape. So we could think of perhaps your yard or even like a parking lot or a little area right outside as a watershed. Here in the Lucky Lab, when water falls here, it moves into the bioswales on the street and eventually into Tryon Creek. So we're in the headwaters of Tryon Creek right now. Tryon Creek flows into the Willamette River, which flows into the Columbia and eventually to the Pacific Ocean. So the Columbia River Basin is the size of France. It's massive. It stretches up into Canada. It's a really, really large waterway. And it's just kind of neat and fun to look at these different watershed maps and just realize that when it rains in some parts of like Canada and Idaho, that comes down and passes not too far north of us on the Columbia River. And we're all really connected through water. And when we're talking about fish, especially, thinking about those connections is just a way to be able to move through different scales of focus area. Okay, so speaking of those little Russian nesting dolls, on the left right here is a map of the Tryon Creek watershed and the sub-watersheds in Tryon Creek, noted by those different colors. And then on the right-hand side, you can see Tryon Creek amidst other watersheds in the Portland metro area. And all a watershed is it's just the area of land where the water drains to one common point. And so that's why you can change your focus. If you're looking at a lake, it's going to be all of the area where water moves into that lake. And for especially for larger watersheds, a lot of the time it's ridges that dictate those watershed boundaries. It's just the line on the map that we draw, because you can say on one side of the mountain the water drains to this river, and on the other side it drains into another. So those ridge tops are often our watershed boundaries. We can do next slide, Glenn. Thank you. Okay, so this is just another map of Tryon Creek and what it looks like from the air. I just like different map photos. There's a lot of photos. I'll move through them as quick as possible. Let's take on. Next slide, Glenn. Thanks. We have an interactive map on our website where you can toggle on different things like canopy cover, impervious surfaces, natural areas, and there's ways to click and link and learn more about different types of activities and notable points in the watershed. Next slide. Next slide. Oh, keep going. Keep going. Keep going until the page is filled out. Thanks, Glenn. So the Tryon Creek watershed is about 20% in natural areas and 80% urbanized spaces. So that photo in the upper right where you see someone's foot and that little seep was taken not very far from here. So a lot of the beginnings of our creeks and waterways just start as little seeps and springs on the ground. And in the case of Multnomah Village, I already mentioned those bioswales out front. I love that, because many of us might be familiar with Tryon Creek in the context of the Tryon Creek State Natural Area, but knowing that those little ditches on the side of the road end up becoming fish habitat really helps us be more tuned into how we move through the world. Little pop quiz time. Any guesses on Tryon Creek's temperature when it meets the Willamette River? You can go ahead and click, Glenn, to reveal that. Oh, I guess I messed up that animation. It's 12 degrees colder. So Tryon Creek is a cold water tributary into the Willamette River. You can do the next slide, Glenn. Okay, moving into fish and fish habitat in the Tryon Creek watershed. I'm going to talk about how fish are impacted by urbanization. I'm going to talk about some of the fish monitoring work that has happened in the watershed, and then kind of some of these bigger picture projects that have both happened and are upcoming. The U.S. Fish and Wildlife Service did a lot of really great monitoring, and so a bunch of the photos and data that I'll be sharing are from them. I have a couple slides towards the end about Tryon Creek Watershed Council, but just as a grounding thing, why am I talking about fish so much? I know our main speaker today is a hydrologist, and a lot of folks are here interested in hydrology. And so just to explain, watershed councils are it's a stuffy sounding name for a type of nonprofit, and they exist all across the state of Oregon. And watershed councils started to become formed after salmon were listed on the Endangered Species Act. So it was community members that were noticing that the waterways in their neighborhoods aren't having fish in them as much anymore. What can we do about it? And so over time, watershed councils have become a bit more kind of baked into the nonprofit sphere, and how Oregon helps to steward our waterways for salmon. So the driver for the Watershed Council is fish habitat and fish passage in this case. Go ahead, Glenn. All right. I mentioned that salmon are anadromous. But the two different shades of blue here, that some of their life is spent in freshwater and some of their life is spent out in the ocean. And when little baby salmon are on their way out towards the Pacific Ocean, Tryon Creek is one of those places that they stop along the way. Why aren't they born in Tryon Creek? I'll talk about it. So when we're talking about wildlife passage and wildlife movement and habitat connectivity, there's a concept called patches and corridors and stepping stones. A patch is kind of what it sounds like, a nice big kind of solid space of habitat. A corridor is something that an animal might use to move between two large patches. And when a corridor isn't enough consistent habitat, then our animals need stepping stones. So this stretch of the Willamette River through the Portland metro area is just kind of geologically straight and simple. So there aren't very many places where we have a big city and a lot of city impacts. There aren't a lot of places for salmon to kind of take refuge. So go ahead, Glenn. There's a couple animations here. This is noted in some big picture planning. You can click next, Glenn. So this stretch of the Willamette needs stepping stones. Go ahead. And it just so happens that there are a couple of creeks that move into the Willamette River. So we have Johnson Creek, Tryon Creek, Kellogg Creek, and then Boardman and Rainierson, and a couple of others out towards Oregon City. So Tryon Creek is here on the west side, providing stepping stone habitat for salmon to move through the Portland metro area. Go ahead, Glenn. That's our watershed once more. Boom. So really, the Tualatin River, you know, stretches all the way up this way, almost back up to the Columbia River, almost like halfway out to the coast. But getting through Portland to reach the Tualatin River, these stepping stones provide that important habitat along the way. Okay, next slide. So this is a fun comic. It kind of illustrates the ways that culverts, which are often these tubes that we build under roads at road crossings, can make it difficult for fish to move in urban areas. Go ahead, Glenn. And again, so there's a lot of different ways that human activities have impeded fish passage. Dams are a really significant one. This is focusing specifically on culverts, and on the next two slides, I'm gonna zoom in here real quick, and you'll click through these next several slides, Glenn, kind of quickly. So sometimes culverts are just, the water is coming out too fast for them, so it's a velocity barrier. On the next click, sometimes there isn't enough space for the fish to get the momentum they need to jump. Next slide. Sometimes the water in the culverts are too shallow, especially the perched culverts. And then next one, sometimes the jump is too high. So a lot of these problems can feed into each other, and replacing culverts can really open up upstream habitat for fish. Go ahead, Glenn. Okay, so who are the fish in Tryon Creek? The most abundant fish that you're probably most likely to see are reticulate sculpin. We also, in different parts of the watershed, have coho salmon, Chinook salmon, coastal cutthroat trout, rainbow trout, and steelhead trout, which are the same species. They just decide whether they're going to migrate to the ocean and back or not. And then also hybrid trout. So there's hybridization between the trout species. We also have Pacific lamprey. Go ahead, Glenn. And Western brook lamprey in the watershed. So this is just a brief recap of some of the fish monitoring work that's happened. You can click through, Glenn. Okay. So basically there was, when the U.S. Fish and Wildlife Service were doing monitoring work, there were a couple main areas in the watershed that they looked. Downstream of Highway 43 culvert, which I'll talk about shortly, and then upstream of the Highway 43 culvert, all the way to the Boone's Ferry culvert. What the scientists saw when they took surveys between 2006 and 2016 across 76 surveys, they were looking for signs of spawning, which can be reds. It can be live adults. Reds are the nests that salmon and other fish will build, or carcasses. And so you see that we didn't find any evidence of Pacific lamprey downstream of the Highway 43 culvert in this type of surveys. And then for adult coho and Chinook and steelhead, we saw some live fish and several unspawned carcasses. There was one season, I think it was 2015, where it was a really, really hot summer, and so the fish came into where Tryon Creek flows into the Willamette River to try and get some cool water refuge, but died before they were able to spawn. And then this is the info for upstream of the culvert. You can see that we did see reds for coastal cutthroat trout in the spring, so we know that there's a good healthy coastal cutthroat trout up in the Tryon Creek watershed. Less so for other fish, largely because of that culvert. Let's go, Glenn. So the U.S. Fish and Wildlife Service collected data in a whole bunch of ways. A lot of this data, or a lot of the information, like I said, in the photos that I'm sharing, we have a recorded science talk on our YouTube channel from Brooke Silver at U.S. Fish and Wildlife. But they did some seining downstream of the Highway 43 culvert, which I'll show you several more photos of. Don't worry, you'll get more Highway 43 in a moment. And then also electrofishing, which is a really neat process where you send a current into the water and it stuns the fish. Their fish bladder brings them up to the surface, they get scooped up, and then we collect data on them. Next slide. Okay, so any guesses what percentage of the fish captured in Tryon Creek over the years downstream of Highway 43 do you think were native species? Dun, dun, dun. Go ahead, Glenn. Oh, yes, I should mention there's a continuum between native species, introduced species, and invasive species. So not all introduced species can behave in a way that has adverse impacts on the ecosystem. All right, 9%. Yeah, which is pretty cool. Yeah. Brooke Silver from U.S. Fish and Wildlife said she thinks she captured the same goldfish multiple times. So that's one of the things. Don't release your pets. All right, Glenn. And this was actually over 7,000 individuals. And I heard someone say sculpin. Sculpin were not counted in that percentage. Native. Yeah, reticulate sculpin. Go ahead, Glenn. All right, how many different species of fish do we think were found in the Tryon Creek watershed? Dun, dun, dun. You can go ahead and reveal it. You can see the options. So there were, yeah, over 20 different species of fish. I see some, oh, I got that right. I got that wrong. All right, go ahead, Glenn. So yeah, like I said, 7,000 individual fish were captured. 99% of them were native. Of the 21 different species, 62% were native. So there were some introduced and only one invasive species fish captured, but several introduced ones. Go ahead, Glenn. This is just a how many question, do you think? How many coastal cutthroat trout do you think were in the survey area upstream of Highway 43? So what we're talking about here is when you go hiking in Tryon Creek State Natural Area, or when you go hiking through Marshall Park, these are some of the places where coastal cutthroat trout were sampled from. All right, go ahead and reveal it. They did not cap, this is an estimate based on all of the data collected in it. There weren't 722 exactly individuals. It wasn't quite that specific, but that's what the abundance estimate was. Okay, next slide. This is just to illustrate the density. I've heard a lot of people say there's no fish in Tryon Creek. Like I hike in Tryon all the time and I never see fish. Well, based on the data that U.S. Fish and Wildlife Service collected, between Highway 43 and Boone's Ferry, so during most of the state natural area, this means that there was about one fish every 100 feet. Above Boone's Ferry, about one fish every 150. And curiously and interestingly, on Nettle Creek, about one every 50. All right, go ahead, Glenn. So how do we know what fish are here and when and how they move? We have our resident cutthroat trout. They're an anadromous species, but we're thought to have a resident population. But as far as fish moving in and out of Tryon Creek where it meets the Willamette River, when I mentioned the electrofishing happens and the scientists are able to collect data on the fish, one of the things that's installed is a pit tag, which is kind of like her pet's microchip. And then there's these things called fish antennas, which go all the way down to the bottom of the creek bed. And essentially each fish, just like our pets, are given a little unique ID, and these are connected to a computer. So you can get a little ding every time a fish moves through. Go ahead, next slide. So the residency time for fish in that downstream portion of Highway 43, but where Highway 43 meets the Willamette River, is you can go ahead and click it, Glenn, and will reveal that the fish spend a week or more, or several weeks, and in the case of coastal cutthroat trout, over 3 months time are spent downstream of Highway 43 and Tryon Creek. Go ahead and go next. So you can see Tryon Creek again is a cool water input source into the Willamette River. Next slide. Okay, this is really neat info on tagging. We have had fish picked up in Tryon Creek that were spawned and making their way out maybe as far south as the Mackenzie River, and then also picked up down closer to the mouth of the ocean, as well as we've picked up fish returning into the Clackamas River that were captured and pit tagged in Tryon as juveniles. Next slide. Okay, so again, Tryon Creek provides that off-channel cool water refuge and temporary rearing habitat for our migrating fish. That photo is of, I believe, a steelhead right downstream of Highway 43. Next slide, because I'm so happy to talk about this stuff, but I'm taking too long already. Boone's Ferry Culvert, if you guys live in Southwest and you've lived in Southwest since 2020 or earlier, you might remember when Boone's Ferry Road was closed down. So there was a culvert underneath the berm of the road that was not very good for fish. Go ahead, Glenn. This is what it looked like sometimes on the downstream end, and then go ahead and click forward. This is what it looked like on the upstream end. There was a really large trash rack there that would get jammed up. You can keep clicking through. This is the photo part. Closer view of the trash rack. This is right where Arnold Creek flows into Tryon Creek, and then it goes under Boone's Ferry Road. Keep going. And then there was also a wetland area. So if you've walked post-project and seen the little fenced off wetland, this is what it looked like before. You can let Amy in and click to the next slide, Glenn. Thank you. Next slide. Oh, that's okay. This was during construction. You can see the new span of the bridge in the upper part of the photo and still look through the pipe. So this is just me during photo. Go ahead and keep clicking, Glenn. So during the fish salvage, a bunch of fish were captured. Again, a lot of reticulate sculpin. Someone in the RSVPs asked, are there any crayfish left in Tryon Creek? There are. We've worked with a student who's collected crayfish data for a couple of years, and we've only found native crayfish in Tryon Creek. And then as well as 2 juvenile Pacific giant salamander who are the inspiration for our logo. And yeah, go ahead, Glenn, keep clicking through. This was during fish salvage, keep going. This is that wetland area, we can keep clicking. Wetland area again, keep going. And so this is just one of the 63-page PDF of blueprints for the project. It's a lot of engineering work. And this is one of the post-project photos on the right-hand side, but I encourage you guys to go check it out in person. Next one. Okay, Highway 43 culvert. A lot of people drive over this on a regular basis and don't even know it's there. So this photo was taken on Highway 43, leaving downtown Lake Oswego, heading towards the Selwood Bridge. Right at that intersection where there's the flowers and you can go all the way up and go to the state park, you were driving over Highway 43 culvert. Go ahead, Glenn. So the Highway 43 culvert is massive. It's 450 feet long. It turns twice, which is a little extra complicated. There's a 6 to 8 foot rise from the up to downstream end, and it's just a near total barrier to fish passage. So we have healthy coastal cutthroat upstream of Tryon Creek, but our migrating salmon can't make it up because of the Highway 43 culvert. So real quick, I'll talk about what's been done, what's happening, and what's to come. Go ahead, Glenn. A lot of advocacy. The Tryon Creek Watershed Council has been a voice at the table. Carl, I can see you blushing from here, but you deserve gratitude, and city staff regularly thank Carl for his advocacy work to move the Highway 43 project forward and keep it elevated. Yes. And gosh, what an effort, because it's really, really complex. There's so many different landowner types, both cities, unincorporated county, Department of Transportation, private property, state parks, and private railroads just for fun. Okay, next slide. So the Tryon Creek, or the Highway 43 culvert, was built around 100 years ago, a little less than that. There used to be an old wooden bridge, and then the railway went in, and then it got built up from there. Go ahead, Glenn. This is an aerial view indicating where the span of the culvert is today. Go ahead. This is the 1996 flooding. Creeks, when we build them in urban areas, I'm sure Nora will talk about this, get really disconnected from their floodplains. And so when we're talking about flooding, water needs a place to soak in. And you can see that right here, the Highway 43 culvert, even though there's a whole canyon and a whole state park right here, it couldn't get through the Highway 43 culvert. So go ahead, Glenn. So this was really prioritized at a regional level. The Lower Willamette River Environmental Dredging and Ecosystem Restoration Project identified, I think, 4 or 5 high priority projects that provided the most ecological benefit and the most effective for money, which even though it's gotten more expensive, again, I'll just, if you go in, Glenn, and zoom in to the next one, we'll focus in on that page on Highway 43 here. The habitat units, which are a measure of complexity for the Highway 43 project, it was rated top because it's expected to increase habitat units by 3,965%. The next one down was 79%. And then like 65 or something like that. Okay, go ahead. So there's a lot that we can do, and there's a really good amount of work that has tried to happen already. So we put the city of Portland put baffles in to create pools back in 2008. Click through. The culvert used to be perched above a pool, and so they redid it so that it's more of a swim in instead of jump in situation. Go ahead, Glenn. The channel used to be pretty in size and has since been kind of regraded. And that photo on the right-hand side, if you click next, if I remember correctly, Another photo post project. This is what it looks like today. It's especially any like habitat managers in the room, like it's really nice to see a project after the trees have really grown up. Okay, go ahead, Glenn. This is just to show low flow, high flow, and relative size of the culvert. It's a little weird. The only photo of someone I have in the culvert is of me. I'm not very tall, but you can see these metal lines are probably at about the like 4'6" point. And you can see them there. And then during a high flow situation, that water is gushing out at my height. Go ahead, Glenn. This is upstream of the Highway 43 culvert. There's a lot of, again, there's good habitat and there's work to be done. So on the right-hand side, that's the entrance to the culvert. If you were to be navigating your way downstream. Keep going. So what has happened? The Highway 43 project, because it's so big and so complex and so expensive and there's so many landowners, got elevated up to the federal level by being included in the Water Resources Development Act, which is a legislative package that basically gives permission for federal government to work on certain water-related projects. The actual disbursement or like allocation of the funds comes through the Energy and Water Development Appropriations. So for the fiscal year 2019, included the Willamette River projects, which was a big win. It was a lot of stuff trickling down from Washington. The city of Portland have a federal relations staff person. And so there's a lot of communication trains happening. So we were able to find out in late 2018 that language was protected for Highway 43. And in 2019, the appropriations passed and gave the U.S. Army Corps of Engineers just over $700,000 for planning and design work. And that's where we are now. The city of Portland is the non-federal sponsor for the project. The total estimated price tag for the project is about $50 million. So the city of Portland are working to close the gap and meet their part of the construction proceed or part of the construction expenses, which is about like $10 to $15 million. Go ahead, Glenn. And that comes through grant writing and maybe anyone in this room with real deep pockets. So the city of Portland, like I said, it's about $10 to $15 million for construction. They're doing some public awareness as far as traffic impacts. We're not sure to what extent Highway 43 will need to close down or not, but people are commuting through, from Westland and Wilsonville outside of the city of Portland. So we're helping them kind of be connected to folks further south of the Tryon Creek watershed that might be affected by the eventual construction of this project. So the U.S. Army Corps of Engineers have completed a lot of the initial surveys and the geotech work. They did some boring samples. The wetland delineation is either complete or just about complete at this time. And the U.S. Army Corps of Engineers hired GRI to do a design documentation report with a couple of sub-consultants. Delve Underground are familiar. They did some of that earlier work in the culvert project zone that I mentioned. And then David Evans and Associates have someone who know the railroad folks. That report is expected to be completed. The timeline moved up. I first heard June 2023, and now we're hearing October 2024. And it'll be considered to be at 30% design at that point, which is pretty great. So we don't know what construction is going to be in around 2027, 2028. It'll depend on funding and things like that. Go ahead, Glenn. But the plan is to have a 30-foot wide, 12 almost and a half foot high open bottom culvert in its place that will be about 400 feet long. And the way to do that is to essentially tunnel through the impoundment above Highway 43 because we can't shut down the highway because it's a transportation corridor. For emergency use, I believe is the reason. And so the gist is that we'll be boring a tunnel underground and then just doing the work in that space. This is an approximate mock-up. The design could, of course, change, but that's a concept image for you. Go ahead, Glenn. So on the left is what we have. On the right is what's right upstream. So this is just a really exciting time. Thank you guys for letting me nerd out a bit about this, about fish and this project. I'm going to talk briefly about the Watershed Council and then turn it over to Nora. But I mentioned that Rolodex thing because, again, joking, not joking. If anyone knows anyone who might help with the project, I'm connected to the project manager who might be able to stay on during Q&A and answer questions. But let's keep clicking through. For now, just to recap about the Watershed Council, we have 3 main work areas. We manage restoration projects in the watershed. We do community engagement at events like this. We have a Watershed 101 workshop program. And then we bring together different restoration practitioners in the watershed and kind of keep everybody connected with one another. We're embarking on some bigger picture watershed-wide planning right now to try to develop really like a comprehensive and scientifically grounded list and understanding of what projects the Watershed Council could pursue that would be the most high impact upstream of Highway 43. And that includes identifying and addressing data gaps and working with our key stakeholders. So we do events like this, like I said, public outreach, workshops. There's some Jackson middle schoolers checking out where Falling Creek enters a pipe. Go ahead, Glenn. And then we have community events. We have watershed-wide events every year where all of our partners, we have like 7 or 8 simultaneous work parties happening. Some of you guys are in this photo and in this room, and I love it. Go ahead, Glenn. And click once more. So this is a before and now photo of some of the restoration projects that we manage. So we're funded by West Multnomah and Clackamas Soil and Water Conservation Districts, as well as by the cities of Portland and Lake Oswego in different amounts for different projects. This particular project is on Nettle Creek in Lake Oswego. Go ahead, Glenn. And then this one is maybe a quarter mile upstream of Highway 43, where Tryon Creek is really in a canyon. There's no trail access, and invasive species have really taken a hold in the last couple of decades. Go ahead, Glenn. This is a relatively new project, but we are doing a lot of work to get replanting happening so that we can really support some long-term shade on the creek. This is the before and after of the project on Nettle Creek that the Watershed Council implemented in 2014. So we started off with the stone bridge on the left, and then we opened up passage, and then the U.S. Fish and Wildlife Service were able to monitor and get data upstream. Go ahead, Glenn. We know that there are other fish passage barriers in the watershed, so that's why we're doing this work to really get a more comprehensive and, again, like scientifically informed ranking of what to do. Working in headwaters areas, this is the headwaters of Tryon Creek. Green infrastructure is really going to connect into Nora's presentation, and it's something that we're looking at as well. Go ahead, Glenn. This is right across the street, retrofitting our existing gray infrastructure. There's things you can do. If you have control over any little piece of green space, you can help it. And especially if you have streamside property in your, in your community or in your backyard, that's something that you can be a part of as well. Resources are on that table. You can talk to me after. I'm going to turn it over to Nora. Go ahead, Glenn. Note, don't transport wood real far because we are going to be losing our ash trees due to emerald ash borer. And use a boot brush. That's a real easy one. Leave no trace. One of the things that we don't realize is that some invasive seeds are the size of a poppy seed. You can stay viable in the soil for 7 or 8 years. So just keeping a boot brush with us can really help reduce the spread of invasive plants. And goldfish, don't dump your aquariums. Go ahead, Bob. Thanks, guys. Okay, sorry, Nora. All right, now to the main event. Thank you. I've just been holding it. Oh, did you want me to sit here and hold it for you? Oh, are you comfortable holding it, or would you rather not? I know you said you maybe prefer not to. I'll be it. Okay.
All right, well, I'm going to get started, but I encourage everyone to go get more drinks. As I present, my presentation gets a lot better the more beers that you've had. So please feel free to get up and walk around. Thank you all so much for having me here today. It's really an exciting opportunity to be able to actually talk to the people who live and work and recreate in the watersheds that I've been studying. So today I'm going to be talking about urban streams. Next slide. To me, urban streams are those that are most fully integrated into our human life. They're the ones that we see on a daily basis as we go to work. They're the ones that sometimes have an important function like stormwater conveyance or transportation even. They're the streams that we seek out on a sunny day when we want to go for a hike. But unfortunately, urban streams are also those that often feel the brunt of development. They're the streams that have been, one more. The streams have been eroded and have become incised and disconnected from their floodplains. They're streams that have been straightened and simplified and lack any element of habitat complexity. And they're even the streams that pose an infrastructure risk. That could be exposed pipes or even undermined bridges. And one of the main causes behind these degraded streams we're seeing in urban systems is due to hydromodification. Oh, one back, sorry. Okay, yeah, good. There we go, good. So hydromodification is exactly as it sounds. Hydro, water, modification, change. It's the alteration of a hydraulic regime in an environment due to urbanization. More specifically, due to unmitigated expansion of impervious areas. So basically, when we expand impervious areas, we are influencing how the water is moving across our landscape, how the water is entering our streams. So increased impervious area results in a higher volume of water entering our streams, a shorter time of concentration for surface water, and ultimately this imbalance between erosion and deposition in our environment. This graph here is called a hydrograph, and it shows discharge versus time. And as you can see, our post-development hydrograph has a higher peak flow and lower low flows, and it's overall a much flashier graph as compared to our nice, smooth pre-development hydrograph. And that pre-development hydrograph supported the ecological and biological processes that a lot of us look for in successful streams. So the physical processes, the hydrology, the floodplain inundation are supporting the biological and ecological processes, or, those are supporting the wetland habitat. They're supporting the fish, they're supporting the beaver. So when our hydrology is disrupted, we no longer have this nice system where we're supporting those ecological processes. So just quickly, like I was saying, that we are going from these nice connected floodplains with lots of riparian vegetation, lots of habitat opportunities, large wood, as you can see in this photo here, to these simplified, like incised streams that are lacking any complexity, any habitat opportunity, and ultimately none of that biodiversity that we want to see in our urban streams. In Tryon Creek watershed specifically, we know that development started in the mid-1800s with homesteading, and then later on iron mining and timber. As you can see in the graph here, like the development in Tryon Creek watershed really peaked in the mid-1900s, but then we see a really intense drop-off in the past decade. And that could be indicating that Tryon Creek watershed has actually almost reached its capacity for development. It's almost as developed as it possibly could be. And our work showed that Tryon Creek watershed impervious area is 26% of the entire watershed. So that's what it's at currently, but we know that development is just going to keep continuing. And so that's something we have to address as well. So we looked at how might impervious area increase with future development in the Tryon Creek watershed. And we did that by looking at Portland zoning codes and basically saying, okay, if every piece of land that's allowed to become impervious does become impervious, what is our watershed going to look like? And they took our impervious area from 26% to 31%. And while that doesn't seem like a huge drastic change, what's really important is that as cities like Lake Oswego and City of Portland have to adjust their stormwater management manuals to meet permit requirements, they have to consider redevelopment projects, not just new impervious areas. So they have to use stormwater management for infill and redevelopment of land that's already become impervious. And this is a really good opportunity because it means we can start employing some of these hydro modification offset strategies to redevelopment. So once we had an understanding of what hydro modification is and what it looks like in Tryon Creek watershed, we kind of started making a list of the symptoms of hydro modification that we see in the watershed. And one important thing to note is that on this graph, you'll see that there's impacts to natural systems as well as impacts to infrastructure. And you'll see that a lot of these symptoms are impacting both. So hydro modification is not only impacting our streams, it's ultimately impacting our infrastructure and our lives as well. As we looked a little longer at this, we realized that almost all of these impacts actually come down to the simple concept of erosion. You can progress like 3, I think. One more. There we go. Okay, so erosion kind of became like our buzzword. It was kind of like what we saw as at the center of a lot of hydro modification. In other words, hydro modification is causing erosion in our streams. So we wanted to figure out a way to measure erosion on our streams. How can we see how much erosion is actually happening in Tryon Creek watershed? And so we wanted to come up with a metric that was really intuitive to a lot of people. This is stuff that's going to be used by city planners, landowners, and other stakeholders. So we wanted to use a metric that made sense in people's minds. Next slide. So we decided to use stream power, which is the amount of energy that a stream exerts on its beds and banks. And we like this idea of stream power because it's a measurement of energy. And energy is something we all learned about in kindergarten and first grade. We get what that is. We can wrap our heads around it. Furthermore, we moved on to the concept of specific stream power. Specific stream power is stream power per unit width. So you can think about it as stream power on the numerator divided by width on the denominator. And we liked this because it directly relates our energy to the physical attributes of the streams that we're working in. Basically, we know that if we are to widen our stream corridor, we're actually going to reduce our stream power. We can, next one. And we really like that relationship. You widen it, you're lowering your stream power. Luckily, a lot of smart people came before us and came up with erosion thresholds of stream power. So what that means basically is a value of stream power over which erosion is thought to occur. You can see there's a pretty wide range of values there, but you would choose the erosion threshold that's most appropriate for your hydrogeomorphic environment. And then if we were to make that similar graph again, we have our threshold, plotted, and then we have our stream power graph, and anything above that threshold line is the erosion that's actually doing the work. Keep going, yeah. Oh, sorry, back one. So that's the stream power that's actually doing the work. That's what we're going to consider the excess energy, the erosion energy. So we decided to use an equation where we calculate the erosive energy of a stream by summing the excess specific stream power, so summing the area under the curve above that line, multiplied by our time step. And then we wanted to put it into units that most people can understand. So we went with kilowatt hours because that's something a lot of us see daily on our microwave, our electric vehicle. So it's something that we could all kind of wrap our heads around. So our next step was to apply this to 5 sites in Tryon Creek watershed. We chose 5 sites that we thought were representative of a range of different conditions in the watershed. And we went out there and we surveyed the geometry of the channels. So we measured things like width, depth, slope, all those elements that we need to calculate specific stream power. We also needed hydrology data in order to calculate specific stream power. And what's really neat about using stream power as a metric is we can actually use variable hydrology, which means we can put in a lot of different flows and calculate a range of stream power values depending on the flow. So our partner in the project, Portland Bureau of Environmental Services, or BES, built a model, a hydrologic model for the Tryon Creek watershed based on real data that basically produced 46 years of hydrologic data that we could then use in our calculations. So we had our stream geometry and we had our hydrology, and we could put those together to calculate specific stream power at each site. And then we could sum that specific stream power, multiply it by 5 minutes, which was our time step in this case, and come up with how much erosion is actually happening. Next slide. And with that, we can produce a graph kind of like this. We have excess energy, the energy doing the erosion versus discharge or the flow, the hydrology data. And what's cool is we can put in different hydrology. So we actually put in hydrology for a pre-development condition, which basically means a 100% forested condition. And then we were able to see, you can progress a few, one more there. Then what we were able to do is compare existing conditions to pre-development conditions and see how much erosion has increased in the Tryon Creek watershed with development. And we found that it has increased 2 to 7 times as compared to prehistoric levels. That's kind of obvious. We know that urbanization is increasing erosion, but now we have this neat way to measure it. Okay, next slide. And again, we're looking at this similar type of hydrograph. Looks similar to hydrograph, but it's actually the stream power versus time. And I know those got a little messed up converting it to Google Docs, but hopefully you can see that it's stream power versus time. And again, we have this really flashy curve when we're looking at existing conditions, as opposed to our nice smooth curve when we're looking at pre-development conditions. And since we know that hydromodification changes the timing and magnitude of flows, we wanted to see which flows are those that are actually doing the erosion, which flows are the ones that are causing the problems. And we actually found that 94% of the erosion is actually happening at or below the 2-year event. So what that means is it's not those big catastrophic floods that are doing the erosion. In fact, it's the smaller, more frequent events that are doing the erosion. And therefore, those smaller, more frequent events are the ones that we need to manage for. There are a lot of existing BMPs and stormwater management techniques out there. Historically, a lot of the focus has been on this blue side of the diagram, where we see things like stormwater retention and stormwater detention. And I have photos of both of those if you want to just hit it twice. So these are kind of our traditional methods, but we kind of started focusing on the other side of the graph, where we see our buzzword again, we see erosion. And we know that there are existing methods to combat erosion as stormwater management techniques, and that includes bypass piping and stream stabilization. One more, but these are can be costly projects, and they're not always the nicest to look at. So we kind of changed our focus to be on resilient stream corridors. One more, yeah. So resilient stream corridors. Resilient stream corridors are urban floodplain environments that have been restored or enhanced to distribute the energy, increase complexity, slow flows, and hopefully reduce erosion. You can create a resilient stream corridor through various methods, including stream bed raising, or raising the elevation of the stream to be in line with the floodplain grading or widening of the floodplain and stream corridor, and large wood placement and beaver dam analogs, which add elements of complexity and habitat to the stream corridor and increase roughness and slow flow. So going back to our equation with what we know about resilient stream corridors, we remember that the big important part of our equation is this excess specific stream power. And we know that specific stream power is stream power per unit width. So to represent resilient stream corridors in our analysis, we decided to double the width of the stream corridor. Go ahead. So instead of using our channel geometry from what we surveyed out in the field or the existing channel geometry, we took that width and basically just simply multiplied it by 2. And with that, we can actually produce the exact same type of graph that we had before, except this time you'll see we have a third curve, and the third curve represents current hydrology with resilient stream corridors. So as you can see, that curve is much lower than the existing conditions, and it's even lower than the pre-development conditions. What we found is that at 4 out of our 5 sites, we could actually overcome the impacts of historic modification simply by widening the stream corridor. And that's really exciting to think about because we know there are going to be future impacts, but we know there are historic impacts, especially since Tryon Creek is almost at its development capacity. So the fact that we can address those with this is a pretty exciting finding. So going back to kind of something I was talking about in the beginning, hydrology is at the foundation of our stream function pyramid. And one thing my boss has said to me is if we get the hydrology right, stream health follows. And what that means is if we can figure out the flows that are causing erosion, if we can try to combat that altered hydrology from hydromodification, then the other elements that we kind of think of as more traditional healthy stream components will follow. You know, we'll get the fish, we'll get the birds, we'll get the riparian habitat once we're able to have this hydrology tuned in and adjusted for hydromodification. So just to sum up what I was talking about today, my first key finding is that erosion in the Tryon Creek Basin has increased due to urbanization. We know that, that's again kind of obvious, but now we have this way to measure it, and we have this concrete fact that we know that urbanization has increased erosion in the watershed 2 to 7 times. Our next key finding is that these resilient stream corridors can help manage for hydromodification. And that's what I was just showing there on the previous slide. We can lower that graph. We can bring down that amount of excess energy simply by employing some methods of resilient stream corridors. And then finally, stream resiliency has a broad impact. And what I mean by that goes again back to what I was saying in the beginning, that hydromodification is not only impacting our streams, it's impacting infrastructure, and therefore it's impacting human life. Resilient stream corridors can bring down that erosive energy that's a result of hydromodification, and therefore they can help combat all of these issues by addressing the problem at the source. And so then kind of just thinking forward about what's next, I want to share that more and more cities and municipalities are starting to look at resilient stream corridors as a stormwater management mechanism. You know, our company has been getting calls from people who want to use these resilient stream corridors to help offset some of the impacts of hydromodification. And municipalities are required to revise their stormwater management manuals. And due to that, they're looking for different ways to treat the impacts of hydromodification. What's really cool about Tryon Creek is that you all, the Watershed Council, is actually already doing things to implement resilient stream corridors in the basin. The plantings that are done, the removal of invasives, those are slowing the water's energies. Those are creating habitat. Those are building resilient stream corridors. And what's also exciting about Tryon Creek is that we have the state park. And the state park is mostly a single threaded stream right now, but there's room, there's protected room in there where we could possibly employ some of these resilient stream corridor projects and have a meaningful impact. And the final thing I just want to say is that I think it's really important to remember that resilient stream corridors can be used in concert with some of the more traditional stormwater methods. In fact, they should be used together in the basin, both resilient stream corridors and more traditional methods. But resilient stream corridors, especially when used with green infrastructure like pervious pavement or rain gardens, can have a really noticeable and broad impact on hydrology and ultimately our basins and how they combat the impacts of hydromodification. And with that, thank you so much to everyone. Thank you to Wolf Water Resources, my firm, who allowed me to play around with this concept a lot, as well as Portland Bureau of Environmental Services, who was our partner on this project. And I think I'm supposed to open it up to questions for the next little bit. Yeah.
I have a question about, I guess my main question, what is eroding? And I'm asking that because at least the lower reaches are on Waverly basalt. Up to about Boone's Ferry, and above that is on the river basalt. So what's eroding? Or is it above that?
Yeah, it's all above the basalt that's there. Yeah, I mean, there are parts where there is exposed bedrock in Tryon Creek Park. And those, you know, sometimes are referred to as being in like arrested degradation, meaning they're not going to get worse, but they're also not going to get better. But a lot of them, we still have soil, silts, sands, and stuff that are being eroded and washed through the system, and those are on top of bedrock. Yeah.
So in widening the streams, make sure that the Tryon Creek stays and deep enough for the fish.
Yeah, so that's something that was a big discussion for the Boone's Ferry project, is because there was going to be widening of the creek. Their habitat elements such as pools are really important, and when it comes to, you know, building a wider stream, you want to have habitat logs that then back up water behind them and allow for you know, fish to have that off-channel refuge. And in a lot of parts, like Tryon Creek right now, it's hard to say with the fish passage barriers how many fish are moving through and stuff like that. Even with the numbers that Alexis showed, they're likely going to be different once we have the removal of Highway 43 culvert. So it is unlikely it's fish passable all the time. But again, it's adding those elements of habitat complexity, and when necessary in a resilient stream corridor, you can grade a channel. If you feel that it is somewhere where it is becoming too shallow, sometimes we'll go in and we'll grade a little swale that allows for a deeper channel while still remaining connected to our floodplain. Yeah. When we do restoration projects like this, we try really hard to maintain any native mature vegetation. That's definitely something that we don't want to be removing if it doesn't have to be removed. We'll go out and do like tree surveys and stuff to make sure we're grading, you know, not in areas with the mature vegetation. But again, there are proxies that we can use, again, wood and boulders to help have that shading element if maybe one large tree or something like that does have to be removed in the process.
And in that proposed project photo for the Boone's Ferry project that I showed, there was like that kind of woven fabric that erosion control mat on the side of the street. You can actually plant right through that. Like willows are a really cool example. You can just cut a branch off a willow and stick into the ground on all the tree grows. And so there's, in any project that's doing some water work, there's going to be a replanting plan that's associated with it. And so getting some planting right and really along the base is something that started. Was that a call out? Was that like a direct call out?
It was a direct call.
Yeah.
Yeah, my only concern is, with Willow, you get a lot of. So how do we feel about that?
We love to.
I mean, yes, yes, But then there's the aspect of the water corridors being parallel to urbanization, so housing, development, etc. So if the water is backing up too far, it's hitting development. So that is something that development people obviously do not want. But the beavers are what we want. Yes.
One thing I'll say about that is kind of going to one of my last points is resilient stream corridors and widening the stream is not appropriate in every location. And I really think it's important to use it with different methods so that if there is a place where we have development right up on the bank, that is somewhere where we're going to have to employ some different type of method. We can still try to work towards resilient stream corridors, but that might not be through, you know, drastic widening of the floodplain corridor. It could be just adding habitat elements to slow the flow and things like that. That being said, what Alexis said, we love beavers. Beavers actually kind of do the job for us. They are ponding the water, they're slowing the water, they're allowing for that. But it is important to consider when you have nearby infrastructure. Yeah, and that's 100% something. That's why one thing, again, what's so exciting about the state park is that we have some room to play. And that's definitely not the case everywhere, for sure.
Yeah, there's like a saying that if your house is flooding, it's in the floodplains. So beavers are restoring that for us, and
But insurance doesn't cover it, and we'll get this.
yeah, they do, they absolutely do, and you know, there was a really interesting presentation at a conference back in April about like working with beaver and how, and so there are things that can be done if the beaver is starting to post up shop in a place that is not ideal. To often like culverts actually are a place they hear the trickling water and they're like, nah, and so they'll start to clean out a culvert. And so there's things that you can put on the ends of culverts to deter them from building there, and you can also create a beaver dam analog structure that entices them to start building somewhere else. And then there's other like vegetation management practices as far as like willows go.
Yeah.
There's different ways to keep beavers from chewing down trees. There's either protective caging of individual or larger stands of trees and then cycle those over time. So it's just one tree, like paint bark, that tends to deter them. So it tends to do a bit of a side by side. Yeah. It's really interesting. A lot of cool work.
Yes.
I'm gonna talk the beaver thing a little bit. I've worked on a couple of other recreating projects where all the other strategies were set aside in favor of bringing in beavers. And there was a two-step process and along with a lot of food, planting a lot of food. And I understand it, right? There's 3 miles of undeveloped land in the state park, and then really all the way to the top of Marshall Park is undeveloped. Are you taking the beaver possibility seriously? Is somebody working on that? Because I think it's got more potential than almost anything else.
Yeah, so there's a stretch in the state park right above the Highway 43 culvert where we're working on some private property, and then we also got Oregon State Parks to direct some additional funds where we're working on a 50-foot buffer for about 700 feet of the length of the creek in Mosaic Ecology. There's a bunch of great canary grass there right now, which raises with insects. That narrows the stream channel and exacerbates this. So for a 50-foot buffer on either side, they've just treated the reed canary grass and are replanting heavily, including with willows, to try and encourage beaver to work there. And we know that there are beaver in the state park, including right now, if you go right up from near High Bridge on the Terry Writer Trail, you can see that there's a cedar that's working on right next to the trail. You can't miss it. And yeah, in this like comprehensive watershed planning process that we're wanting to undertake, looking at promoting beaver habitat and stuff, one of the things that's on our radar.
But I think they're finding over in Oregon, planting up road, they're planting up ocean, they could cut the field.
Exactly, yeah, that was kind of an indication that it might have gone through the existing preferred resources. I learned also that aspen are one of the preferred species. There's a whole list of them, those preferred beaver species. And you're totally right, that they do our jobs for us and better than us. There was a multi-million-dollar stormwater treatment facility in the Gresham area. And it just finished getting constructed, and then beavers moved in, and a bunch of the folks that work on the project got really concerned because the beavers were changing the hydrology of this detention ponds. And there's a scientist named Katie Bolzer, she said, wait, let me collect some data. So she collected up and downstream data of pollutants and sediment and temperature, and beaver did better on every single one. It is